everyone. This will be a talk about explanations and responsibility in black box decision making. This is only a part of a wider project done by me and my two colleagues, Nenad Filipovic and Andrea Berber. We are all research associates at Belgrade Faculty of Philosophy. The motivation for this research project came after reading a bunch of literature on the ethical problems of using machine learning models for high-stakes decisions. Machine learning models generate predictions, and based on them, some important decisions are made in fields such as medicine and healthcare, criminal justice. They're also used for job application assessments, for decisions on insurance and loan qualifications, and in other fields in which decisions have important consequences for human lives. The problem with using machine learning models for such decisions is that there are errors and biases known to be involved in machine learning processes of decision making. One example that was written a lot about, even on popular media, on blogs, is the notorious Compass software, which is used in the state court systems for predicting risk of violent crime in the near future. Based on this software's predictions, decisions are made about the defendant's freedom at every stage of the criminal justice system, from setting bond amount, bail to parole release. You can see on these two charts below that the risk scores are skewed toward low risk for white defendants. That's the chart on the left, while on the right the scores for black defendants are not skewed toward low risk categories. They are distributed somewhere about equally. The problem here is that it is not just the case that the software only makes different predictions for white and black defendants. The problem is that also predictions fail differently. On the table above, you can see that for white defendants, they fail twice as frequently toward the optimistic side, predicting low risk when later it turns out that the defendant did commit a crime, while for the black defendants, the predictions fail twice as frequently toward the pessimistic side, the predicting high risk when later it turns out that the defendants didn't commit a crime after release. That's an example of systemic bias in machine learning models. Another type of problems are individual errors in the decision-making processes. In diagnostics, for example, this can have serious effects. Cynthia Rudin mentions a case when the word portable printed on X-ray images was included in the diagnostic prediction by the machine learning model, even though the word only referred to the type of equipment used, the portable X-ray. It had nothing to do with the state of the patient and had no diagnostic significance. These types of errors are especially problematic with black box models, where you don't know the exact process of how the model reaches the prediction, and if the model is giving relevance to some parameters in the data that it shouldn't give relevance to. Responses to problems such as these, found in the academic literature and in the machine learning community, focus mostly on explanations of how the black box models function. Metaphorically speaking, they are focused on opening the black box. Responses by academics, NGOs involve requesting explainability of artificial intelligence. They consider explainability important for ethical or trustworthy AI. Responses from within the machine learning community involve developing technical tools which provide explanations and insight into the working of black box models. Now, our research aims to answer two main questions. First is, does the use of black box models for decision making create any new problems in virtue of its inherent characteristics? And the second one is, would adequate explanations, which are the supposed remedy for this black boxness, solve the problems such as the ones just illustrated? Because of the limited time, I will here discuss only the first one. As for the second one, I can only give our spoiler that we argue the answer is no, and I can hint that it has to do something with the answer to the first question. Our findings are, as for the first question, that machine learning does introduce novel ethical problems. in virtue of these two inherent and unique characteristics of the machine learning method. First is semi-autonomy of the machine or the machine learning model, and the second are the unprecedented quantities involved in machine learning, which raise the decision-making processes far beyond the cognitive grasp of humans. Consequences of these properties of machine learning are distribution of responsibility between man and machine, loss of human control over the process of decision making in several ways, and a further consequence that stems from these is an inherent obstacle for assigning responsibility for potential harmful outcomes which result from errors or biases. I will now elaborate on each of these points. For the characteristics of machine learning that will turn out to be ethically relevant, semi-autonomy is actually refers to self-learning of the machine learning model, and self-learning in this context only means that the model means refining or adjusting the weights of the parameters, where weights indicate the relevance of a parameter for a particular output. So the higher the weight assigned to the parameter, the more important the parameter is for a particular output, and the output can be a classification or a prediction. The model learns the weights by itself according to the patterns it observes in the training data, and then in making predictions for new cases, for some new input, the predictions are based on the weights established in this learning phase. It is important to highlight here that the engineers don't have control or insight over the exact process of how this weights adjustment or learning occurs. So no human has direct control over or oversight over what the machine learns and what classifications or decisions it will make. As for the quantitative leap, it refers to the quantities of several levels which have had an unprecedented growth in with machine learning. First is quantity of information, which involves the amount of data, their dimensionality, the storage required. Then there is a complexity of machine learning processes, the information flow occurring between input and output, which is so complex that it is impossible for a normal human to trace this information flow. Then the speed of processing also, processing of information with which humans cannot compete. And the leap that occurred with machine learning in these quantities leads to a transcendence of human cognitive capacities. As a result, the machine learning processes are in principle impossible to be grasped by humans. So what is new in black box decision making is an inherent loss of control. Semi-autonomy means delegating the most crucial determinants of a decision to a machine or a machine learning model. The quantitative leap complicates or even precludes humans to properly inspect or react to the decision-making process before, during, or sometimes even after its execution. The decision-making process of a machine learning model does become inherently evasive to human control and inspection. The quantitative leap makes a twofold problem for control, actually, since humans cannot trace or comprehend the processes inside the black box because they are too complex. This can be termed that there is no internal control, but also they cannot trace or inspect all the processes overall, since there are too many of them taking place too quickly because the machines are so efficient, and there are bound to be more and more decisions made than there are humans who are able to sit down and inspect these processes for errors or biases, and we can say that this is a lack of external control. Problems with control carry over to the assignment of responsibility. No proper control makes problems for preventing or predicting a faulty or harmful outcome. It also makes problems for inspection of correctness and fairness of the decision-making processes. The loss of control also opens a question to which extent are human beings responsible for the decisions made by the machine. Some authors would argue against human responsibility in this context at all, and there are also potential problems for implementation and application of legal regulation, but this opens a completely new topic. To conclude, The advantages of machine learning systems, which are handing an enormous number of tasks to a machine, and also the speed and efficacy with which these machines far surpass humans' abilities, it is precisely these advantages that make the machine learning systems immune to human control and surveillance, and make the assignment of responsibility inherently problematic. For now, it is not clear whether and how we could keep these advantages while solving the problems with responsibility. Thank you for listening.